cloud. And then I'm going to start to share screen. Okay, so what we will do today is continue our discussion on NumPy array, okay? And on Monday, we started to, no, the annotation, why didn't, okay. And we started about NumPy array, okay, discussed something like indexing, slicing, and if you recall, we also use dot dot for the slicing, is it? Yeah, so what we today are going to do, continue with the note. That a quick start from the official, but I added some more stuff. Okay, so today we will start with shape manipulation about NumPy array. Okay, so the first part, what we will do is let's take a look regarding random number generation. Okay, there are a couple of ways in NumPy you can do random number generation. The first one over here we are going to show is random integer generation. Okay, and then you specify the shape of the NumPy array. Okay, so anyway, it's going to generate some random numbers, but arranged in NumPy array. Okay, so here specify the shape is going to be 3 by 5. Okay, and this is just an integer. Okay, and you can specify the range of the integer from 0 here says to 100. Okay, and here it shows some random number. So this is one way to generate some random integers. The second one you can call, it's also from NumPy random. And what over here is called rand. Okay, so this function, the rand is what you can plug in. You can plug in the shape also. Okay, so over here, we keep having students coming in. So over here, the shape is separated by what? By a comma. Okay, so both, hold on, we have more students coming. Okay, and we apply the first argument to the second argument. So here, what is the method parameter type is individual parameter. Then you plug in with individual argument. Okay, and this basically also specifies the shape. Okay, so it's 3 by 5. And what is the next one going to show us is just the random method. And with this random, you plug in with a tuple. Okay, did you see over here? Okay, plug in not the single argument, not the two arguments in the previous case, is it? And here is some single object. Is it? This single object is a tuple, and the shape you provided in through the tuple. Okay, so this is also a way. And in both of this case, the random just generates some random number range between 0 to 1. Okay, so this is some random number generation. And then what next try to show, okay, so here we call that a random plugin with tuple provided the shape, is it? And then you can do floor, is it? Do floor. So floor over here times 10 of the random number because it's between 0 to 1, is it? And we have another student coming. Let me get in. And because you times 10, so you get some number between 0 to 10, is it? And you're going to take a floor, is it? So just take the integer part of that number, is it? So that's how of this number come from. And I need to admit. Okay, so that's regarding the random number generation. And what we just said, how to reshape. Is it NumPy array? Hold on, let me admit. There are two methods you can call, two function. One is called revel. Okay, and with revel, if you don't plug in anything, it's going to flatten your array. Okay, whatever the dimension is, flatten it. You can also call reshape and then specify the shape, because this is the original array A. Is it what we print out here? That's the original array. The original shape is what? Is 3 by 4. Is it 3 by 4? So 3, 4. That's the shape. Is it? And here you said the reshape to what? 6, 2. Is it 6, 2? Yeah, so did you see? It has 6 rows and 2 columns. Okay, 2 columns. But here, be careful, revel and the reshape, they returns an array with the modified shape. Okay, the original array not to change it. Okay, so be careful. And also you may ask, what's the difference between revel and reshape? Okay, generally speaking, revel is faster. Okay, it's execute faster. Okay, so that's revel and the reshape. And there is another function in a NumPy you can reshape with NumPy array. It's called resize. Okay, it also plug in with the tuple. Okay, and the resize, be careful, it modifies the array itself. Is it? So in this case, A's shape change from 3, 4 to what? To 2, 6. Is it? So we see the result. Okay, and you can also do reshape something like this. And the first one, is it? The first one is a number, and the second number is negative. Okay, so what does negative dimension mean here? Okay, the negative dimension, then that means the first dimension is going to be 3, and the A is 3 by 4, so it's 12. Is it? So whatever that should go, so 12 divided by 3, so it should be 4. Okay, so if you provide some dimension as -1, that means it will go by the calculated result based on the other dimension. Okay, because sometimes that's what you would like to have. Is it maybe this is a variable change, then you can keep changing, is it? Yeah, so then it's more flexible. Okay, so that's the usage for when you do reshape. You can also use -1 to make your shape more flexible. What the next part to try to show is, in NumPy, you can kind of combine multiple array together, okay? And over here, the concept, then we call it stacking together, okay? And along different axes, is it? And in NumPy array, we know axis like 0, that means first dimension, is it? Dimension 1, is it? And axis is 1, then dimension 2, is it? Something like that. Okay, so let's see. A and B, we use random number generate 2 array, is it? So A looks like this. This is B. Okay, so A and B, we have this 2 array. Hold on, let me get admit another student. And then what does this mean here? So it's called numpy.vstack. Okay, and then plug in with A and B. Is that A and B are 2 NumPy array, but then in this case, you plug in as a tuple. Is that? So what this means, VStack, it's vertical stacking. Is it? So if you take a look at the result, yeah, it does vertical. Is it? It vertically align, combine 2 array together. Is it? So it's changed to what? To 4 by 2 array. is it? And then how about the other one? H stack. H says horizontal stacking. Is it? The result looks like this. Is it? So kind of expand the original array. Is it? From 2 to what? To 2 by 4. Is it? So that's this two methods, V stack and H stack mean. And there is another method, corresponding method called column stacking. Okay, so column stacking, it's similar as H stack. Okay, so it's equivalent to basically these two. So if we do A and B with column stack, you're going to expand the array horizontally. But be careful, okay, in the next part. So over here we have array, is it A? And this time array A is what? It's 1 by 2, is it? And B is what? Is first dimension is 1, is it? Is 1. And then you do column stack. Okay, admit another student. This time the column stack, it's not going to expand the array horizontally. Okay, what in this special case, what it returns a 2D array. Be careful, okay? So that's what it returns. It's going to return a 2 by 2, not a 1 by 4. Okay, you're assuming like with H horizontally, that it should change it, expanded to shape 1 by 4, but did you see it's not? It's changed to 2 by 2, okay, in this special case, okay, with column stacking. But be careful, okay, the difference is if you call H stack, then you will get a 1 by 4, you expand horizontally. Okay, so that's the difference. Okay, then we can take a look, the shape. If you want to get arrays shape, Numpy array shape, you can call the shape method, okay, shape function. Hold on, we got a student, I need to admit. You can directly call the shape and then it will tell you the shape, okay, like for the A, is it? And then, so we have the A, is it? And then let's take a look, because this is the first dimension. First dimension, is it has 2 items, is it? Because here we have comma, so comma, this is the second dimension, suppose. This is the first dimension, okay, so first dimension you have 2 items, okay. So that's why you have the shape as 2. And what next to try to show? Is it like this? You do A, is it? And so that's the Numpy array. And then you do like a first dimension, you said, okay, I'm going to do slicing. And with this specific word called new axis. Okay, new, and then this going to allow you to do what? To change that to as a 2D column vector. Initially, it's a row vector, is it? It's just like you just have a single row, is it? Then if you do the shape, did you see the shape is 2 and 1? So that means first dimension, you have 2, is it? I have 2 rows. Second dimension, you only have 1 items, is it? Yeah, 1 item. Okay, so the shape is different. Initially, it looks like what? It's 4 and 2. Is it? Looks like this. And now it's changes, so we need to be careful here. So A2, is it A2? So this new axis, is it? So it will align it as a single item. So did you see? You have the inner brackets, then you have the outer brackets. Hold on, I have another student. Okay, so that's why over here you have 2 rows. Keep having students join, come. Okay, so in this case, it's going to be 2 by 1. So you have two rows and a single column. Okay, so that's just so you can do the new axis, and then with the column stacking, you can also apply this technique. Okay, so for that array A, then you do the new axis. So you convert it from row vector to column vector, 2D column vector, and for B, the same thing. Then you apply column stacking, so it's going to expand horizontally, and you can, of course, do H stack, the same thing. Okay, so this is the idea about vertical and horizontal stacking. So you expand the array, and versus you expand the array, you can also split NumPy array into some smaller arrays. Okay, so here it shows an example. So we have a 2 by 12 array. So this is a 2 row and 12 column array, and then you call horizontal split, how many you are going to split? Split it into 3, So the first one and the second one, you can get each individual array, So we can also do this. Okay, what the next one try to explain is about copies and views. Okay. And over here, so we have a NumPy array with 12 numbers, And then you said B equals A. Okay, so that means B also point to A, So it's a deep copy. Yeah, it's a shallow copy. Okay, it's point to the same as whatever A is. And then if you do B shape, it will also change A's shape. You see, initially A is what? It's 1 by 12. Now it's changed to 3 by 4. So be very careful here. Even though you do everything on B, but it's impact A. Okay, this is because it's a shallow copy. Okay, shallow copy. And then next one try to show us is, it says Python pass mutable object as a reference. Okay, so it says function call makes no copying. Okay, so here you define a function, and you can, if you want to know the ID of the specific object in Python, you can use this function called ID. And here then you call like the ID A. A is an array. That's what it gives. And if you call that function, did you see it's the same thing? And here it says ID, unique identifier of an object in Python. And in this case, A is an ND array, NumPy array. A NumPy array, so it's considered as Python object. So it has some ID. Okay, that's what this part shows. And we have a student, so I'm going to admit. And next, okay. And what next one try to explain the view concept. Okay, the view concept. So A is an array, anyway? So it's an array. And if you do view and assign to C, okay, so view is kind of you take a camera to look at something, So what you look at through the camera, it's the real thing. But your camera can only see part of the thing, part of the thing. So that's kind of the concept. So of course it's not A, but its base is A. So this is true, Then the question is, if you change your views shape, will it change the base shape? It's not. Did you see? Base shape still keep the same. This is easy to understand. This is just like the camera, is it? You can always rotate your camera angle, is it? So that's what you take, you rotate your views angle. The original object is that object's angle not changed, is it? So that's why its shape is not going to be changed. You can view your camera horizontal or vertical, is it? But the thing is still going to be there. It's not going to be rotated horizontal or vertical, is it? So that's the concept, okay? But you need to be careful. If you do some specific thing, is there some specific operation on specific item for the original thing, then of course it's changed. Is it? This is kind of like you take a camera, then you saw some thing and you say, okay, get that object to change. Of course, it's going to change on the original object. It's not on your picture, is it? Okay, so that shows the shallow copy, okay? So why we need to know this is because whenever you slicing an array, it returns a view of the NumPy array, okay? And yeah, so let's see. So as you do slicing, as we do slicing, here on the row, on first dimension, we take all of the dimension. On the second dimension, we take the first one, is it? We take the first one, and we're starting the first one, is it? And what are we going to, so that's our thing, is it? And we also take the second one. And what next we are going to do? So this is the view, is it? Part of the original array. So that's what this part is. And you're going to assign all of it to what? To 10. Is it to 10? And we can see A did get changed. Is it modified? Because that work is on the original array. Okay, even though it's through view, is it through view? And why you can do this, it's because NumPy array is what? Element wise, okay? So this is because of element wise, okay? So that you don't need to use a loop, do one by one. Hold on, we have one student coming. And, but you need to be careful. You need to be careful, okay? If you do this, so here you have the view, etc. And if you instead do s equals 10, can you turn off your audio? That's different, okay? So this means you reassign variable s to a single scalar, That doesn't mean you want to change all of the elements to 10. Okay, so these two are different. So we need to be careful when you do the operation. And if you want to deep copy, then you can specifically call copy. Okay, then it won't change the original array. Okay. Okay, what is the next one? Section going to show is about NumPy arrays advanced indexing. Okay, advanced indexing. Here, advanced indexing, what it says, it's going to be triggered by what? Array of type of integer or Boolean. You will see it's quite interesting, okay? Or a tuple that says with at least some sequence object, okay? And or some non-tuple sequence object. So that's called advanced indexing. Let's take a look at more examples. Okay, so let's see here. This is the original array. So original array looks like what? You have 1, 2, and then you have 3, 4. Then you have 5, 6. That's the original array, is it? It's 3 by 2, 3 by 2, is it? And then you're going to do A and with indexing. If you take a close look, within the square bracket, you have 2 square brackets, is it? And with 2 square brackets, you do what? You have some integer value. Integer value. Is it separated by what? By comma. And over here, you also have comma. Is it? We also have comma. So these 2 square brackets is what? It's integer indexing. Okay, integer indexing. And because it's separated by comma, this first part means regarding first dimension. And this second part after comma means regarding second dimension. How do you get a single item out? Is it? So what it looks for? It looks for from the first dimension 0, second dimension 0. Is it? First dimension, second dimension. So you're going to get 1 out. So that's true. Is it? And the second item is what? From first dimension 1, second dimension 0. So you're going to get 3 out. Is it? And the last one is third row and the second column. Is it? So that's this item. So it's 6. Okay. So be very careful here. It's kind of looks messy, but you need to be careful. As here is regarding first dimension, regarding second dimension, separated by comma. Is it? And within each dimension here, it uses some sequence. Is it? To identify, so this is called indexing. Indexing, okay. Okay, and then next one. So that's integer indexing. What's the next one? Try to show Boolean indexing. Okay, Numpy array also does support that. If you take a look here, A, is it? That's our array. So this is the array, is it? It's 1, 2, 3, 4, 5. So it's 1 by 5, is it? And within the square brackets, A greater than 50. Okay, so this is some condition check. So that means if it is true, is this greater than 50, greater than? So it will do element wise. Check, is it greater than 50, greater than 50, greater than 50, is it? And this will return true, this will return true. So you will only have those 2 return true. So whatever true, it will go to that indexing extracted item out, okay? So that's how Boolean indexing works. If it is false, it won't retrieve it. And then next, let's take a look at the next one. Next one is what? Do element wise, module 40 and remain 0 if it is true. So this is going to be true. This is true. So only those 2 true. And with those 2 true, then you do what? You do quadratic, is it? So that's how you come up with it. All of this operator is regarding element wise. But over here, we do Boolean indexing, okay? And then next one, try to show some idea. So here we have array B. Okay, array B looks like this. So it's 5, 5, then 4, 5, then 16, 5. Is it? So this is our B array. Okay, B array. Then what we want to do is we want to what? We want to do sum. Is it? We want to do summation. Is it? And we want to do summation sets -1. So what does -1 mean? Is it -1? So this basically it's for axis. Is it? Axis in Python, if it's -1, that means the last axis. Okay, so you use -1 for indexing for the last axis. Okay, for the last axis. And but it's do sum. Okay, it's do oh, I got to the wrong. So here is 16.4. So you are going to do sum on last axis. What is last axis? So axis 0. So here it's 2 dimension, is it? It's 3 by 2. Is it? Axis then, so last dimension is axis is 1. Is it? Axis 1 is what? It's basically column. Is it? It's column. But your sum, what? Sum by column. Is it? So this by column, so this is 10, this is 9, and this is 20. Is it? And what you wanted to retrieve. So module 10 equals 0. So this is true, this is true. Is it? And 9 is false. Is it? That's how you pick out those 2 rows. Okay, those 2 rows. So basically, if you do sum with negative, it's equivalent to you specify axis is 1. Okay, so be very careful here. What negative means, okay? And if you do sum is 0, that means axis is the first axis, okay? Then in this case is you retrieve all of the rows. Is it all of the rows? Okay, so here all of the row item that's going to be added together, and the module 5 remainder is 0. That's what this next part shows. Okay, so anyway, so we already see, is it? So Numpy array is broadcasting rule. Broadcasting, so basically it's element wise, okay? So we keep see all of those examples. Okay, what next one try to show us is about fancy indexing and some indexing tricks. Okay, and this is very useful because the data analytics deal with all sorts of data. It's a lot of times it's huge data, and you are not going to work on the complete data. You may just want to get a partial of the data. How do we do it? It's all operating manipulation around the indexing. So if we are good at all sorts of indexing tricks, techniques, it's help us a lot. Okay, so let's take a look more. Okay, what is the next one? This is what the array looks like. Is it? So it's 8 by 4 array. Is it? And then what over here we do is you want to do something. Is it? And you pass in. You just pass in some one-dimensional sequence. Is it one-dimensional sequence? So what does this mean? This means you want to do some indexing. Is it? You want to do some indexing. Along what? Along the first dimension, okay? So first dimension, you're going to retrieve this row, is it? And the sixth row is this one, is it? Yeah, so did you see you get those 2 rows, is it? And what next is the last row. The last row is here, is it? And what's next is the third row, is it? And the result, basically you can see, is it? You just take out some row from the original array, but you rearrange the sequence, is it? So if you need to do something, is it, to manipulate the data, you can borrow this technique. And then let's see the next one. The next one, this time, did you see you have comma? is it? And previously we also see this case, is it? And so this is regarding first dimension, is it? And this is regarding second dimension. And you're still going to do indexing, is it? So this time it's not just on the first dimension, on second dimension, you're also going to do something, is it? So what you will get, you will just get a 1D array, is it? Okay, so then next, let's take a look, a more case, okay. So if you take a close look, this case, so this is regarding the original array, is it? So it's the same as it. So that's what we are going to get, is it? So that's matches this part. And after that, you are going to do what? You are going to, here we have comma, is it? So on first dimension, so regarding this, on first dimension, what we do? We do slicing. Slicing with what? With everything. So all rows. Is it? All rows. And on the second dimension, you're going to do what? You're going to get to 0. So that's what you get. And then what? Then go to the third one. That's how you come. You see, the third column got shifted to the second column. Is it? And following that is the second column and the third column. So here you use this slicing and indexing, you combine them, you rearrange the original array, okay? And what next one try to show, let's take a look. Okay, so A is from 0 to 11, is it? And then quadratic, so that's how of these numbers, is it? Of this number. And what I is a NumPy array, is it? I. Okay, it's NumPy array. And you are going to do what? We are going to do A sub with this I. This is a NumPy array, is it? And basically that means what? That means the result is going to be the same shape as I, as I. So what you're going to get the first number or the second number, you're going to get it twice. Get it twice. You repeat. And then the fourth one, 0, 1, 2, 3. So you get this number, is it? So you keep getting the same number, is it? And the result, so the shape in this case is the same as the I, is it? As the I. Okay, so that's this example. And then next one, let's see. So here you have J array. The J array is 2 by 2. Is it 2 by 2? Then you said I do A sub J. Is it? A is what? A is 1D. Is it? So it's 1 by 12. Is it? And then you said AJ, and J is 2 by 2. So basically, then in this case, A's shape. Did you see A's shape? Then it's going to be the same. So you're going to have an array, not A's, okay? You're going to have an array. The shape going to be the same as J's. Okay, so that's how this indexing works. And then next, let's see. This is also quite interesting, okay, in the real world. So this represents some palette, color palette. As a color, we know it's red, green, blue, is it kind of, and each one has some zero number from 0 to 255, is it? Okay, so combined together, you have certain color. So if RGB are all 0, that means it's black, is it? If it's all 255, it's white, is it? So anyway, so using this array, is a 2D array to represent some palette, color palette, is it? And then over here, we have another NumPy array, is it? So this NumPy array is what? It's 2 by 4. Is it 2 by 4? And then you say, okay, I'm going to create a new array. That new array will be based on this palette, but with the shape of this image. Is it? So what does this mean? So this is generally the image shape. Is it image as a shape is 2 by 4? Is it? So you have each pixels. Is it? And each of the pixel you needed to have some color. Is it? How does that color come from? Come from this palette. Then you need to define. Is it? So that's how this will give you some image shape as what here it defines. Is it? But the specific pixel color will be determined by this palette available. Okay. So that it tells you how to retrieve the corresponding color from the palette. Is it? So here it says, okay, for the image, the first pixel, is it? It's going to get what? Get black color. Is it? That's how this part shows. And then the second one, is it? It's going to look like what? To look like this. Is it? And the third one going to be this, and the last one is still going to be black. Is it? So that's going to be what? To be the result corresponding to your image's first row of pixel, as the first row of picture. Okay, and then for your image, the second row of picture, you will get the corresponding color pixels, is the color pixels. So the result then it's going to be 2 by 4 by 3, is it? So that 3 basically represent each specific color, is it? So you can see this is quite useful, is it? Because we also know, like when you do machine learning, is it? To deal with image, it's all 0 and those numbers, is it? The 0 to 255, is it? Okay, and what next one shows here we have an array A, is it? And then we have another array I, is it? And the I then is going to be used as indexing, okay, as indexing. Array A's initially shape is what? Is 3 by 4. Is it 3 by 4? And what is the shape of this? This is 2 by 2. Is it 2 by 2? And so the shape will follow what? Because the I has 2 rows, is it? So your generated array will also generally, the first dimension, it will be 2, is it? Will be 2. So it's going, the generated, it's not an A's, I'm wrong here. So here is the generated arrays dimension, is it? So it's going to be expanded to what? To 2 by 3 by 4. The original is 3 by 4. But here you are going, the base of this generated array is going to be what? Is to based on I, is it? So that's how the first dimension, okay, so follow the 2, is it? And then the second, the third dimension is going to go as the pick some items, is it? From the original array. So that's how this works. So we can take a look, okay? So this is the first dimension, is it? So first dimension, within the first dimension, you have what? 0, 1, is it? So 0 and 1, yeah, 0 and 1, is it? So exactly, okay. So that's how this shows fancy indexing. And then next, let's see. Okay, so you see here you have a 2 by 2 J array, is it? And this time, you're going to have both array plugged in to A, and the generated array is going to have 2 dimensions generally, okay? So overall, abstract level, the generator is kind of like 2 dimensions. The first dimension is slicing with off the original. The second dimension is going to be based on this J dimension. Is it the J dimension? Okay, so let's see. So the first one anyway is going to take all from A's. So we can take a look here. So this is A, this is A. You're going to take, anyway, the first dimension is going to take all from every row, is it? And then based on the second and the third, is it? You're going to go by what? You're going to go by 2 first, is it? 2 first, and then 1, is it? So you're going to following what? Following 2. 2 is here, is it? And then arrange it as 1. So 1 is along A's. It's 1, is it? So you're going to keep arrange for each row of this, is it? So that's why for the resulted one, if you take a look, is it the first dimension? It's going to have 3, is it? And the second and third, so this one matches J's shape, is it? And the first dimension still go with A's. So go with A's. Okay, so be very careful here, okay. Okay, and then it's going to be interesting if you do IJ like this, okay, with both array. Then in this case, it's do indexing, is it the shape? So then in this case, I and J must have the same shape, okay, same shape. So be very careful, okay. And so for this special case, the second dimension is always going to pick with what? From the originals, what? The second or the third column, is it? The third column from A, is it? And the first dimension, the shape will follow what? Will follow I's, is it? That's why the new array's dimension is going to be 2 by 2, okay? So that's this result. And here it says, if you recall fancy indexing, is it also suppose you can also plug in with any sequence, is it? So here you have L, is it? And if you apply to tuple, is it? Then you can generate tuple, and you can also plug in as indexing, is it? And you can also get the similar result, okay? Okay, so that's regarding that part. And over here, let's see, IJ, we already know, is it the array? And here we have S, okay? And S is that it's going to be generated with what? It's going to generate with I and J. So that's what it looks like with S NumPy array. Okay, then we have A, is it? We have A. And over here, you can also, S is a NumPy array, is it? And if you apply tuple, is it? Then this is going to be a sequence, okay, sequence. And you can also use this to do fancy indexing with the original A array, okay? But if you directly plug in S into the original A array, so S is this multi-dimensional NumPy array, and if you do that, that will report error, so that won't work, okay? So, but if you do the tuple, okay, you convert it to some sequence, then it will be similar as you do the indexing, okay, indexing. So then it's going to work. It can pick out the needed items from the array. Okay, so we run out of time.